Very good afternoon, ladies and gentlemen. I'm happy to welcome you back to our fourth tutorial session, which will be conducted by Mr. Yuri Leva. He will teach you about multimodal language understanding for low resource languages. Yuri is a guru in this field, and I feel really lucky that he agreed to accept this kind of invitation to be a tutor at our summer school. So please welcome the guru. The floor is yours, Yuri.
Yep, so should I speak into the mic or can I speak with the voice? Just like this.
Just direct your voice into the mic for proper recording. Thank you.
Okay. Okay, dear audience, colleagues, students, just guys, very nice. It's very nice to see you here. And today we'll speak about multimodal language understanding for low resource languages, especially for Ukrainian language. And I'd like to start with a short intro about myself. So my name is Yuri Laba. I studied at computer science at UCU. Then I received my master's degree at Lviv Business School. I have 5 years of commercial experience in machine learning. I was mostly working in green energy field, automotive, predictive maintenance. But those are not only domains that I was working on. And currently, I'm studying at PhD here. So my journey at PhD started at 2023. Before it was like so mainstream to study at PhD, and I've done my first research I've done some researches in terms of my bachelor degree. Also, I have research even in business school, but it was like mostly marketing research. It's not the scientific research. And then before the program was opened, I was working on like research towards Ukrainian language. So my first paper was released even like before the PhD. I wanted to like I really when I was working in the company, I mean business sector, business domain, it was like a bit boring, I believe. I had like very big dreams that in research there are like it's a top interesting tasks that you may do within the research field. And here is my email. I believe I already know some of you because Anton is my colleague. I know how Odnohrupnik, I know from here, so I know Anton for a very long time. Yuri, right? Yuri, Markian, sorry. Is a master student where I was like helping with assisting some courses. Yeah, so that's very brief info. Actually, I had a lot of slides, a lot of information to share, and I believe we don't have so much time, but we'll see. So we need to make this session as a conversation, okay? And yeah, my next slide is agenda. So I plan to speak about, I know that our session is about multimodality, but my first research was about one modality, I mean about textual modality. I was working here with word sentence integration for Ukrainian language. And this is not, as I mentioned, not a multimodality, but it was so important research for me because it was like our first research and I faced the reality for the first time. I mean, in terms of doing research, in terms of all the complex stuff that exists there. Then we'll discuss briefly a current solution to achieve multimodality. And then we'll discuss how to do it in the low resource languages. The next step should be visual words and disambiguation for the Ukrainian language as the next chapter of my first research. Then the next topic is stability of multimodal LLMs when we're dealing with synonyms. It's a very interesting topic, and I believe we'll practice this topic in our practical part. And the next step will be semantic of token embeddings in Ukrainian language. So, but let's start with the question to you. I'm sorry I missed your intro section on the very first day, but like as you guys shared information, you have interest in NLP, you have experience in NLP, and I'd like just very few words from you. I'd like to hear very few words from you, so that like I better understand your expectation.
Okay, so I probably know not a lot about NLP. So I know some preprocessing is data, how to deal with stems and so on. I have like the helicopter view of how the transformers work, but the multimodality in the NLP it's still like uncovered topic for me. So I hope to like get a better understanding how it works in this session. So those are my expectations.
Yes, thank you very much.
Yeah, the similar goes for me. Like I have some experience in classical and natural language processing, some understanding of transformers and spiral plans, but no experience in multimodality. And I guess that I could learn some nice tricks and how to deal with some problems with text and non-based text. And maybe I'm not sure, but maybe I'll learn something that will help much in some unsupervised context with unstructured textual data. How to process it to extract some insights, maybe.
Yep, I also have like basic knowledge about NLP, and I cannot understand how multimodality works. And also I want to understand more about Ukrainian language and its processing and what's the state of its development today.
Yeah, I have also like base knowledge in NLP, a little knowledge in multimodality, and so on. And my expectation from today is to know like what the potential problems in this sphere. Like, can we ask ChatGPT to do everything about that, or we should build some models?
I have a little experience in multimodality. It was a small project in generative AI to generate emotions, because there is some challenges in to generate emotions, especially with people. If you write like generate sad girl to some stable diffusion models, they generate very ugly faces. So I'm interested in this field of multimodality, how different approaches combined.
Last but not least, I'm an expert of the European Union in language technologies, reviewing proposals, European projects for language technologies, including NLP and multimodalities. I'm really curious if we're coping with this.
Thank you very much for sharing. It's valuable insights for me. But I also have an expectation from our today's session, because actually, guys, so I'm working on this research. I mean, here within UCU, And I know that some of you are master students, some of you maybe students of other universities. And like the whole point of today's presentation from my side is to share with you some ideas, some like, let's say, project topics, so that we can collaborate. It's really crucial, so that's I don't want to make this session like I talk a lot of stuff and I can talk about this like whole day. So we need to, at least from my perspective, it's very nice to identify like what do you like, so that we can collaborate in some way. Make sense to you? Okay, as I mentioned, I will start with word disintegration for the Ukrainian language. It's not a multimodality, but I will try to make it fast. But it's very important, I believe, to start at this point. And yeah, so I don't know whether you're familiar with word disintegration task. I would say that this is like a very niche task. You know, it's not very famous. And when I started work on this task in 2022, I believe. Yeah, so it was like I didn't know much about that stuff. As I mentioned, it's very niche. But the point that task this definition is the following. So we have an input sentence. Сторож пряснув ключами, смикуючи важкий здоровий замок. And the point is to identify the correct meaning of that word, right? So we have to know that in that particular sentence, the word замок means пристрій для замикання дверей. Okay? Do you have any thoughts how we can achieve this? I mean, do you hear about have you heard about some models that do this? Any ideas how we can, I don't know, try to solve this problem? Just share anything.
So we can train the model to assign some probabilities to each of them.
Please use your mics. For recording.
So so probably we can train some model to take into account the context and to assign some probabilities to different meanings. For example, if there is the building, or it is some small object, or like some another entity.
Yeah, makes sense. Maybe you have heard about some solutions for lower source, or just your personal idea.
Just the first thought that was like on the surface.
Got it. Thank you.
Well, more ideas? I have one. After you go ahead.
I can share mine.
Okay, so obviously this problem is about understanding homonyms. Yeah, words that have the same look but different meanings based on context.
Yeah, homonym is like part of that stuff.
Yeah, and only contextual analysis can help us.
What do you mean under contextual analysis? It's like you mean some NLTK stuff to determine, I know, part of a speech and doing some tree search solution, right?
Yes, based on the previous words, sentences.
Yeah, there is some solution, and you even added a slide here. So Babelify.
Oh yeah. I would like to involve multimodality in that. You have different pictures of different words having different meanings that may help disambiguate this term. So if you go multimodal, that might help better than just using NLTK and all the other good old-fashioned AI for that.
Yep, also makes sense. But yes, thank you very much for sharing nice ideas. When we started, and by we I mean that there is also another author of this article here. So we've done this with Voldemar. we didn't know so much about like approaches, how to mitigate the issues, but there was a conference deadline. So all our like solutions that we've developed here, it was like it was pure, I would say, creative process. And that's what I like about the research, about this part. So we were thinking much about, at this point, about, you know, how to say that, the process, the academic process, because we were not in the academic the days. But yeah, so we started with graph methods, Babelfy. I don't know much about that stuff. I mean, how it works in the nutshell, but actually the same solution on the high level as you mentioned. And so we evaluated that solution on part of our data set because they don't have any API, so we did it manually. The spoiler is that the results for Ukrainian language weren't great. So what about actually high resource languages such as English language? In English language, everything is a bit simpler because they have money and they can like employ some annotators, and they have just classification data set. For example, you have the captain ordered the ship to drop anchor, and you have the definition. And then you train a classification model to solve that task. Okay, so what about Ukraine? To the best of our knowledge, there is not such a data set for Ukrainian language, and it's a quite complicated project to gather such a data set. It's not even about money, but it's a bit about money, but also about the complexity of Ukrainian language. But there is some data set, словник української мови. And this is a very important part. It's like a first milestone because this is the data set that we used for evaluation of the Ukrainian VSD task. And we'll discuss the structure of this data set in the next slides. But the point is that this is programmatically accessible resource dictionary in Ukrainian language, which contains a lot of words, definitions, and samples, examples of usage of such words. The sentences there, or examples, they are a bit outdated. Yeah, it's like I don't know, some text from 18th, 17th centuries, like some old stuff. But it's a very important work. And I mean, the work is still in progress. So people are doing this dictionary, making it online. And by this link, you can access this dictionary. And as I mentioned, in programmatic way, right? So you can download it actually. And it is a very, very useful part of resource that we'll discuss today. Yeah, in terms of VSD, so it contains word looting and other definitions of word looting. And within each of the definition, we have a lot of, not a lot, but examples, right? And I believe you may feel that we found that solution here because we have word, like with the disambiguation, we have definition, and we have a lot of examples. So probably we might use it to train something. Yeah, as I mentioned, dictionary can be accessed as a JSON file, right? Simply, you can use it as a JSON file. Yeah, here one more example, maybe simpler. Not simpler, it's just my favorite word kosa with the disambiguation. So kosa is the platinum volossia, and коса as довге волосся. And here is the first important part. So do you know the difference between homonymy and polysemy? Yeah, guys, yeah. So this is a polysemy, right? And it's very complicated stuff because it's very hard to distinguish even for people what is the difference. Okay, you can distinguish between заплетене волосся and довге волосся, but believe there is some cases when the difference between polysemy is so philosophical, and there are a lot of such cases. And homonymy is a situation when the words have the same, they are written in the same way, but they have totally different meanings. And in here we worked with a homonym in this research, and it's very important because we also experimented with polysemy, but it was very, very hard for models to distinguish between polysemy definitions. Yep, so just some screens from the online resource. You can distinguish between polysemy by using some marking, I would say, from the dictionary. And yes, so the total amount of words in the dictionary is more than 100 119,000, and after cleaning we receive only 3,412 homonyms. We've applied a lot of cleanings in the evaluation data set, so it's actually very basic stuff. We removed very short, very long lemmas. We removed some missing senses, some missing parts from the dictionary. And yeah, so we received the version, the polysemy version of the sum dataset, right? You might see here, for example, жінка щодо дитини, яку вона народила, мати, right? Мати as самиця щодо своїх малят. So mate, I mean, here we have like those polysemic definitions. And so that we can like simplify our task, we created a homonymy version of the data set where we just assume that all of those glosses, all of those definitions of the homonymy word is like something same, right? Any questions so far?
Was it manual work to combine these homonyms?
No, we all of that stuff was done automatically because of from our side automatically, but because some people do a good job while digitalizing that dictionary. So you can create the you can understand with Python script that all of these definitions are related to the same word.
So basically, we took all the. So we actually took all the meanings of some word and combined them into one single description of that word in some sense.
Yes and no. So we have lemma, mate, right, as mama, mother, and we have different polysemy definitions. Polysemy means that they have sometimes very philosophical difference between the definitions, right? Because жінка щодо дитини, яку вона народила, жінка, що має або мала дитину, про що-небудь дуже близьке, рідне, you may all relate this to mother. And another definition, so we have мати, as уживається на значення того, що комусь належить що-небудь, so it's a totally different word. So, and we like combine the polysemy definition per each word.
Oh, okay, got it.
Yeah. Any other questions? Anything?
Let's imagine we do not have like this structured way to have all the polysemy, and we need to filter out somehow homonyms from polysemy. What maybe you have some ideas on how to approach it to at least partially automate it?
I don't know. I don't have actually ideas how to do this. So your question is like, how can we, without some label that all of these definitions
Yeah.
relate to the same word?
Yeah, just glosses and lemmas, but not like the structures of this are different. I mean,
Yeah, I don't have an answer. Okay, I understand your interest in unsupervised. You'll speak a lot of that, but actually, you may use here some
data sets.
I would say you may use here just the cosine similarity as a very basic point. You may just input this sentence, and just try and this sentence, and you may hope that the distance between those two sentences will be lower than distance from this and this.
So I should like seek for some threshold that will be good enough to just split the data.
Yes.
Maybe some clustering on top of it would fit.
Maybe.
Okay, thank you.
Okay, and now about evaluation process. So we like very simply, we have the benchmark, right? So we have a data set where we in some way may evaluate performance of Ukrainian language on words and disintegration task. And the point is how to do this, right? First problem that you will encounter that you have a different, I don't know how to say it in English, but it's like відмінювання, right? So I don't know the word cases. So the word mate as a mother might have a different cases, so that you either have to have, I don't know, some dictionaries with those cases, or you have to have another solution. And for us, another solution is UDPipe. So it's like also a graph-based model developed by some Czech university, and it also works. I mean, they have a version for Ukrainian language, and based on what I know from the community, everyone is using this for now to remove cases, let's say, to make the word to be in the initial form. So now, evaluation process. We have the word lemma, замок. We have examples, сторож прив'язаний ключима, I won't continue that reading. And we have possible lemmas. So it's actually, I would say, we speak now about a homonymy context, right? We assume that all of this is just to represent some particular sense, and we have just two senses of the word zamok, right? Then we calculate embeddings of each possible meaning, I mean polysemy meaning, and the embedding of this whole sentence. And then we take only the embedding of the word zamok, right? You can do this, I mean, because if you're familiar with the transformer, you understand that when we receive the final embedding, so the word zamok has to contain the information or attention weights from all the other tokens in the sentence. So it was the point to use just the word zamok, right? So we believe that it should contain enough information to distinguish between those two homonymy meanings, right? And we basically just calculate cosine similarities between those two definitions, those three definitions, and just choose the maximum. Just choose the maximum. Any questions?
So we took the cluster with the
Clusters that contain the maximum cosine similarity to the word zamok. I mean,
all the
yes. So we calculate the distance between this sentence and zamok, this sentence and zamok, and so did the same here. You see, we have 3 cosine similarities here, 2 cosine similarities here, and we just chose the, as you mentioned, cluster or list of definitions that contain the highest cosine similarity. And we know that this represents, for example, zamok as a building and this zamok as a device. So if any of the polysemi definitions represent zamok better, we will choose it. Okay. And the next part is annihilation metric. It's very simple. We just use accuracy, whether we identify correct sense or not. So one more time, we have lemma, we have gloss. What is gloss? It's a definition. And we have examples. And based on those examples, we try to define the correct gloss, and we just predict it and compare predicted context or gloss with the real. Any questions? Everything is clear? Okay. So you mentioned that you are already familiar with the transformers, so that I will just very briefly discuss it, and we have 100 slides more, so we have to go fast. Yeah. Actually, as input, you have sentence or lemma. You've done all the transformer stuff, you've done the tension, right? And you receive the embeddings. You may receive embeddings from each layer of the transformer, right? Agree or disagree? Okay, so very simple question. Can we, so for example, in BERT, if I'm not mistaken, you have 20 layers, right? So can you receive embedding from the third layer? And does it make sense? And by embedding, I mean output of the attention block.
Yep, it's like just straightforward.
Yeah, that's just, as you mentioned, straightforward. In transformer, you have some attention, some layers that contains tensions, and you can receive the output from each of the transformer layer. And the point is that the rule of thumb is that the top layer, or I don't know, everyone, some people. It depends who like it depends on the counting type, but top layers represent something very general in terms of language, and the bottom layer represents something very specific. So when you do the prediction, when you use embeddings, you would like to use probably embeddings from the bottom layers, right? Make sense? And actually, we are here now. So we receive embeddings from each layer. Then we have pooling operation. So what pooling done in terms of transformers? Do in terms of transformers. Okay, so you can receive embeddings from each of the layer, and you as you may see, the shape will be the following: number of tokens, number of layers times embedding size, right? So, but you need some, let's say, just array, just one-dimensional array to represent sentence or whatever you need, right? You can just normalize. And the point is that you can choose embedding, for example, from last 4 layers and normalize them. You can choose embeddings, you can take embeddings from last 2 layers, and you can also do some min-max pooling or some other pooling. And it is like a crucial stuff when you're working with embedding and you try to, when you work with transformers and you try to receive a proper embedding, because you may significantly change your predictions based on the pooling strategy you choose. So here is a visualization. You have sequence length, number of tokens, hidden size, and batch size. For now, for us, it will be not so important. And you have a different pooling strategies. For example, use first layer or last hidden layer. For example, when you when you just let's say have you used BERT? I mean in some Python application, right? And if you open Hugging Face, you may just open it right now. You probably will enter BERT in Hugging Face, right? So you will see the mean pooling strategy. So when you put some sentence into the BERT, it actually computes all the layers based on the trained weights and just calculate mean pooling to represent your sentence.
But why this
mean pooling, not like max pooling?
Because mean pooling is the obvious one, the most obvious one. It's just the simplest. I don't know. I can't say that there is some research that states that the mean pooling is the best pooling. But for example, in our case, we also use the mean pooling.
Like the average pooling and not the.
No, the average. I mean, like me. Okay. We may just let's discuss it later. And yeah, so we've done such a comparison. We have different pooling strategies and various models that we have tested. So we evaluated that stuff on the benchmark that we gathered based on the sum dictionary using the evaluation process that we just discussed. And we received the accuracy metric 0.7735. So that's why we decided to proceed with this model and try to fine-tune it. Any questions to all of that? I mean, not just this table, but everything that we discussed previously. Or clear. Okay, I have a question. So do you know that model? Have you ever worked with sentence transformers? Okay, so okay, I will just discuss it very briefly in the next slides. But so the fine tuning. Okay, so we have a benchmark, we have metric, we have evaluation process, and we have the baseline results. So we try to fine tune the model in order to improve our baseline results for the VSD task, and we use this model. So I have personal stuff with this model because in my career, it's not a model, it's a family of models. And those models work very nice for semantic retrieval, semantic similarity tasks, because so it's very interesting architecture actually proposed by the Ukrainian scientist Irina Hurevich. And the idea of the architecture of this model is you have two, and I have a marker here. So it's okay. Probably let's discuss it within the break, because for some reason I assume that some of you worked with that model. But if no, we will just continue. Okay, and as a training approach, we use triplet loss, or like as one of the loss function from the metric learning family of loss functions. Have some of you worked with a triplet loss? Can you elaborate on the tasks that you've done?
Actually, I used the triple loss in the in the same network for face identification when you compare the input image of the person with the negative sample and the positive sample, and try to make it closer to the positive sample.
Yeah, exactly. So probably very powerful idea, and still so simple, I would say. Yeah, and we also use metric learning here in order to fine-tune the model for the VSD task. And I would say, so Anton, you were asking about like unsupervised way, and it's probably very interesting idea we used here. So we have anchor, like some sentence. For example, стояв красивий замок. We have positive sample. Красивий замок виднівся за горою. And we have negative sample. Замок висів над дверима. And we want to minimize distance between anchor and positive and maximize difference between anchor and negative. Make sense? So, yeah, maybe a couple of words just from, I would say, mathematical stuff of the question. So, here is loss itself. We have a distance between anchor positive, anchor negative, plus some margin. And this distance is a p-norm distance. And p-norm is actually generalization of different types of vectors norm. And in our case, we use Euclidean distance. So just basically dot product. But you have also used Manhattan distance or even L infinity norm here. To be honest, I didn't hear about that norm. And a bit about logic of the triplet. So the loss is calculated as the difference between these distances plus some margin. And when we have distance from anchor and positive plus some margin less than distance between anchor and negative, means the model performed well and the loss is 0. And when we have the opposite situation, the loss is positive, which indicated that we have to fine-tune the model more. And the main question, how to create the fine-tuned dataset. And here is the next important part of the next milestone, and this is UberText. So UberText is a data set for Ukrainian language that just contains a lot of sentences from various resources, from various Ukrainian resources. Right? And yeah, you may see here that they have sentences from Ukrainska Pravda, Громадське телебачення, so you can access all of the data just on Hugging Face and download it. And yeah, as I mentioned, just contain a lot of words. And the idea here was calculate embeddings for each word and cosine similarity between each word, each sentence, and each sentence. Yeah, pairwise distance between each sentences. And in that case, in such a way, create anchor positive and negative data set. So just imagine you have some sentence in data set that contains word zamok. I know zamok стояв красивий, right? You have 10,000 sentences from the data set. You will play between zamok стояв красивий and all of the other 10,000 sentences, and you just assume that the sentence with the highest cosine similarity will will be your positive sample, and the sentence with negative cosine similarity will be not negative, but the lowest cosine similarity will be your negative sample. Make sense? And this very nice approach because it's also unsupervised, fully unsupervised. Yeah, and here are some sizes that we created. It's not so important right now, but yeah, in such way we created the fine-tuned data. We also applied a lot of cleaning there, so it's a huge part of the research, applying some different filtering strategies and investigating the data set. I will not go deeper into details here, and still we have something to clean. Sometimes we have the bad, we identify the lemma in the bad way. Sometimes like we have a very close sentences. I mean, you have anchor, головним чином вантажівки завозять в підконтрольні території, and the positive sample головним чином вантажівки завозять на підконтрольні території, right? So the two different journals write the same article, but use someone different symbol, and we have also such cases. I mean, it's easy to filter them, but it was not the point in that time. You have seen the distribution of lemma, so we have a lot of analysis of the data set, and we have results here. So with such an unsupervised data set, and we don't use even the whole Uber text because we was just testing the approach, we still improve the accuracy for the VSD task. Right. In our library, or let's say libraries that will be released in some future, we have a lot of different analysis like accuracy per part of lung, various accuracies. Again, we'll not go into details here. And yeah, also we analyze the risks that the model just predicts the most popular sense, but it's interesting that so in the sum dictionary we also have the frequency of sense usage, right? So how frequent is this sense? And we might see that, for example, for the third sense based on frequency, we even have better performance. I mean, we improve performance more than, for example, for the first sense. Right? Any questions so far?
Maybe you have evaluated like with confusion matrices to know what sense is false positive when it's trying to classify the first one, the most popular, or like the third one, or the second one.
Yeah, we had this idea, but we didn't perform that analysis in that time. Yeah, and summary of this part is that we compiled a new data set to evaluate the VSD task for Ukrainian. We have proposed this approach, and we achieved the improved performance for Ukrainian language in that task. So that were the main outcome, and here we unfortunately stopped. So there are a lot of ideas that might be done within this approach. Just simply retrain that stuff, retrain with the full capacity, I mean, with all the data sets. And if some of you are interested in working with that stuff, it would be very beneficial because we already have 9 citation of that paper. It was released at UNLP in 2023. So I mean, people are reading that work. That model is deployed. I mean, you can access it on the Hugging Face, and it is a part of Lung UK organization, and it's a second top downloadable model. I mean, as a part of Lung UK. And I believe people are experimenting with that, and a lot of analysis might be done here. How does this model generalize maybe on other tasks in Ukrainian language? How that approach maybe like improve the model performance in other tasks? So a lot of I believe we'll continue that research because a lot of interesting stuff are there. And yeah, so that was our first section about research without multimodality. If you have any questions, just ask them right now. If no, we move to the multimodality. Yep.
Are there any possible approaches for solving this task, which probably exist in papers on English language or some other language?
Actually, yes. As I mentioned at the very beginning, the VSD task has much better performance for English language, but the problem is that often they fine-tune it on the supervised data set, right? And in that time, we also didn't test the performance of generative models such as GPT on that task. Maybe they have also better performance. So yeah, probably done stuff like that.
So on the previous slides, there were the largest accuracy achieved. So actually 77% doesn't look much, but what is the human level of performance on this data set, if this was measured somewhere?
On human level, no. I mean, I understand the question. It's not a perfect number, but that paper, that research was not about like creating solving the issues. Like we were just two part-time workers on the data set. The point was just to develop the solution, the approach to fine-tune. We even do not have GPU to fine-tune it properly, right? We just find it's a child fine-tune, I would say. I mean, you probably can receive the huge much better performance with that approach. But the point was just present the approach.
So 78% was received without even the GPU?
No, we used one GPU probably, but there was an outage with an electricity and that stuff. Even within this winter, everything was like falling apart, so we just trained it for a couple of hours.
So, but even with one GPU, it is pretty good.
Yep. Yeah. Maybe questions, or that's it for now. Okay, let's then move to multimodality, the main idea why you kind of came here. So first question again from my side, what is multimodality?
Like make the model, make the large language model make several things at once.
What do you mean by several things?
Like analyze the text, analyze the images, analyze the sound, and try to combine those inputs into to make the this single or several outputs.
Yep, partially correct answer. Maybe another ideas?
Like you have one input, for example, text, and as an output you have image or text plus image, like for image captioning. It is example of multimodality.
Also partially correct answers. I mean, great answer, but we'll discuss a multimodality as you mentioned, with image and text, right? But the point is, right now in the research world, from my understanding, you may have the various modalities. And by modality, for example of the modality might be the measures from the sensor. So it's also as a modality. So the model might be not only 3 modalities, it might be, I don't know, 10 modalities. It very much depends on the task that you want to solve. I don't have an experience, so I can't say what you will achieve with sensor measures, but that is actually the definition of multimodality. And I'm saying that because I made a mistake, and in the agenda stated that I will provide you definition of multimodality. Yeah. Okay. Now, but let's stick like to the simple baseline, right? So images and texts. We'll discuss how to combine images and text. And first, great, my favorite model. I slept with it for many times. So Clip. Have you heard about that approach? Learning the transferable visual models from natural language supervision. Any insights from those who heard? Have you used it? Great. Do you know who developed that model? OpenAI in 2021. So I read that paper a lot of times, and here is a couple of I would say bullet points from my understanding of the model. So let's start with the intro. The whole idea of the Clip is, again, use unsupervised way or semi-supervised way to fine-tune something, right? It's not even about multimodality. It's not even was in that time multimodality. It was about image classification. So the point is that conventionally a fixed set of predetermined object categories is used for training and prediction. Example, image level. So you just have image and class, basically, right? And the Clip is proposed to have the train task of predicting which caption to learn image representation from scratch, right? So they wanted to predict text based on image utilizing some unsupervised way. And then they created a data set of 400 million image text pairs. Any questions to the idea? Okay, maybe it will become more clear here. So learning from natural language is much easier to scale compared to the standard crowdsourced labeling for image classification, since it doesn't require annotation. Pretty clear, right? Right. It also has an important advantage over most unsupervised or self-supervised learning approach, in that it doesn't just learn a representation, but also connects the representation to language, which enables a flexible zero-shot transfer. Not so important right now, but the important thing here is, as I mentioned, they wanted to train simply just classification model in unsupervised way, semi-supervised way. And in order to do that, they created a data set web image text. So how that data, what actually this data set represents? So they just use simply frequent words in English language. And for example, they went to the Wikipedia, they find automatically the word, I know, for example, zamok, as a caption to the image, and then, okay, so here's an image description and here's an image. So we have now image and label, and we have like a huge amount of such samples. Simple? Yeah. Yeah, I probably will share, or you may just read this paper. How do they combine that? They have a huge number of queries, and queries, as I just mentioned, frequent words in English. They applied some bigrams in order to enrich at least, but the idea is, as I just said. Any question to this? Okay. Yeah, so they collected in such semi-supervised way, they collected the data set of text and image. And the next point is very, very simple. So they have two encoders, image encoder and text encoder. Basically, image encoder is VIT model, visual transformer, and or ResNet. And a text encoder is also some kind of transformer. And so they have embeddings. How to say that? For example, you have image of puppy, right? And you have a text. This is a puppy, right? And you have 9 other possible definitions of that image, right? Some random, but you know the correct answer because you gathered from the Wikipedia image and captions, right? And you just randomly find 9 other definitions, right? And the point is that you have the encoded image, encoded 10 possible labels, and you just simply minimize you try to minimize the cosine similarity between image and right label. So image of puppy and the text, this is the image of puppy, and you have to maximize distance between all other definitions of the image. Maybe I will it makes sense to go here. It is a pseudocode of the training of the clip. So as I mentioned, you have image encoder and text encoder. So with ResNet or transformer part, let's say for text encoder, right? You have some L2 norm. It's not so important, and you have 2 matrices. So those 2 matrices, they represent the mapping from image to the shared multimodal embedding space, and we have the same matrix for textual modality. And now please ask your question.
So actually, it's just a triplet loss?
No, it's just cross entropy.
Yeah, but it's some sort.
Yes, in some sort, it may look like a triplet loss, and we'll speak more about triplet loss in the multimodality case. But the point is that you have just logits, right? So you have a probability of the correct class and 9 other or some like 9 probabilities of incorrect classes, and you just maximize the probability of the correct class while minimizing the probability of incorrect class. And by correct class, I mean that again you have image and caption, and you have some other number of captions within the batch. So the point is actually to learn those 2 matrices that okay, again, simple words. So we have an image encoder, we have text encoder, okay? Then the point is to somehow align image and text, right? And for this purpose, we have to learn 2 matrices, right? Learn projection of image to embedding and projection from text to embedding. And we learn these projections by minimizing not minimizing, just optimizing the cross entropy loss. And what we minimize distance between the image of the dog and caption dog, and maximize probability of this happening, and minimize probability of image of the puppy and some all different classes that we randomly choose.
So here our logics are
Probabilities. Oh, okay, not simply probabilities.
the or this
It might if you have, it's not so important what's it, vectors or not. So again, imagine you have image of puppy, and you have 10 possible classes, right? Image of puppy, image of pig, image of monkey, image of something else. And this will represent the probabilities. Probabilities this image be image correspond to each of the labels, right? and we know the correct answer. We know that this is an image of the dog. We know it because of the semi-supervised nature, how we gather the data set. And those logits will be the probabilities of image belonging to each of possible classes. So if you have one image and 10 classes, it'd be 1 times 10. It's not embeddings, it's just probabilities.
Okay, good.
Other questions, or everything is clear?
We increase our data set like 400 millions of samples. We should have some examples that are way too close to each other, like our truth diagonal sample, and for example, like you have puppy and you have dog, yeah, almost probably something like even more closer. How to handle the situation when our data set is really huge?
You shouldn't care about that case when you have so huge data set. That's the answer. Because the point is that okay, maybe more details. So you have batch size, you have 32, right? And you have one image. Okay, you have you take 31 images and 31 text labels, right? And now you sample 32 samples from the huge data set. And in order to build this, not triplets, but the correct, incorrect stuff that we just decide, you choose only now from 32 samples. Okay, it's not. I understand that it's not an answer, but they do not mitigate such issues because this is a really huge data set. In that period of time, the same data set was used to train GPT-2 model. It was 2021. Any other questions? Okay. So, and again, about predictions, something that we just discussed. So the model works like this. You may choose any image, you put different classes, right? So you compute the image of the embedding of image, embedding of text. Now you have the example, you have 10 classes here: plane, car, dog, bird, and here's an image of the dog, right? And then so you calculate embeddings for each of the class, and just then calculate dot product between image embedding and text embedding, and you choose the maximum. And this is your prediction. Again, about training details. So there are a couple of clip versions. Some of them use they basically use different version of ResNet or different versions of visual transformers. But the point is that all models are trained for 32 epochs, and a very large mini batch size was used. 32,000 was used, and mixed precision training. The largest model took 18 days to train, but probably it was 2021, so it was a bit outdated. It is a bit outdated GPU for now. And the prompt engineering started already those days when it was not so mainstream again. So it was 2021, and in the paper they also state that, for example, you have just a label dog, right? And when you add a photo of a dog, you'll get the better accuracy. Also about their short capabilities, it's actually a great outcomes, I would say. For example, the model that was trained in semi-supervised way right, showed the better performance on ImageNet that the model was actually trained on the ImageNet. Yeah, and here is a list of data sets such as SIFR 100, SIFR 10, a lot of data sets where the clip showed zero-shot clip without any fine-tuning on that data set or part of the data set, showed better performance than the state-of-the-art approach for that particular data set. Right. Okay, so we just discussed the first method to achieve multimodality. I have to hear some questions.
So clip is in some sense this technique and can be used with it's not like the complete architecture, but in some sense like the attention block, if it can be compared. So it can be it is the ideas that can be used with different transformers and visual transformers.
Yes, basically, yes. I mean, it actually is a transformer. So they do not develop any brand new transformer. They just basically took part and took some width, so two transformers, and they just minimize. They learned, they developed a loss function to learn the projection to the multimodal embedding space. And they learned that projection by maximizing probability of having actually minimizing distance between the image and correct label and maximizing distance between image and all other labels. So yeah, that's it. That they actually added two, let's say, projection layers, the learnable layers, so that they map to the same space. That's it. Very simple.
Probably we can increase this the amount of dimensions you're working with. Okay? As you show the slides, 2 dimensions, probably like it's the basic in this article paper. And if we increase, for example, add third dimension with some audio encoder, yeah, it's one way. And another way, if we add dimensions with another text encoders, will this affect accuracy and performance?
First question regarding audio domain. There is already an architecture called WATT, W-A-T-T, and it uses the same approach, but for the audio dimension. When I started my PhD, I also wanted to work with audio, but it is so complicated domain. A lot of various alignment has to be done here. So because for now there are not so many people in PhD, I just dropped the audio modality. But I believe, yeah, there might be a lot of findings there. You may add also a video modality. You may add, as I mentioned, sensors modality, right? Different modalities, and just try to learn the same space for all those modalities, or some clusters of modalities.
Probably the problem is to collect the data set.
Yeah, but that is the hugest problem, and that's why I started with my VSD ideas, because there are, I don't like to name Ukrainian low resource language for now, because it's already, a lot of researchers are working on Ukrainian language. We have a lot of resource, but still you have to there are a lot of stuff that you have to collect manually. Yeah, that's the truth. Okay, maybe other, maybe you have some other questions. Or so maybe from my side, what I wanted to add, basically, you may receive the embeddings clip. You receive the embeddings from the textual query, and you receive the embedding from the image. And the point is, you now can compare those. I mean, they are in the same space. That's why you may do something with them. You may use them as an input to the classification model. You may use them as an input to some search. You may search images by the text, just calculate using cosine similarity. And yep, CLIP is a great model, but the problem is, for me at least, that the CLIP doesn't work with Ukrainian language. Or Ukrainian language is represented in CLIP with Russian language or other Cyrillic mnemonics. So I don't know how to say it. Yeah, Cyrillic. Another dial, I mean, its CLIP is not sufficiently hard. I also don't know how to say that. I mean, there are various different architectures, cat leap, for example, but they use more or less the same idea, the same foundation to learn the shareable layer, right, between text and image. And we have another direction, Llama. Do have anybody heard about that? Okay. Again, the idea behind all of that is very, very simple. So we have two encoders for images and for text. For images, we have clip here, and for language, we have Llama, right? This Meta model is produced by Meta. And as a training data, we have instructions, and these instructions are generated by GPT-4. Do you know what is instructions in terms of fine-tuning the large language model? So you basically have image and have captions, and you ask, or I have a sample here. So for example, you have image and some I don't know, labeled or semi-labeled, or how to say that, have description of the image. For example, a caption, right? Just caption from the Wikipedia. And you ask GPT model to generate actually questions based on the caption that you have. And then you fine-tune the model based on those captions. And the point is, how do you fine-tune? Again, the idea is very simple. The idea is now to not to learn not to project the image and text into some similar space, but just project image to the textual modality. Right? That's actually it. And we have two components of the loss. So we have language model and loss for textual prediction, which means that we, for example, next token prediction or masked language modeling. And we have contrastive learning to align visual and textual features, right? And maybe for this, let maybe just I want to show it to you. So that so the idea is very, very modeling Llama. Yeah, so this is a transformer implementation of the Llama. For example, we have forward punch, right? So we have image and text as an input. A lot of code here, but the idea is very, very simple again. So we have image, right, encoded, for example, with a clip. And then we have a layer that map that image to the textual modality. Again, a linear layer. And then we just substitute the embeddings of image in the text, in the textual embeddings. I mean, literally, when I was working that, I thought this is something like more complex, but we just actually compute the same cross attention. I mean, the same attention, but instead of just using text, we also use images, and we have one more layer that project image to textual modality, and then we do the same as with the simple transform. That is the idea of Llama, and this is actually that some cross-modality attention that approach is called. So you just it just works like this. Some questions here. Llama is an open source project, and yeah, I tested it in my task that we'll discuss later. What also I can say here, I know you just it would be nice if you play with Llama. Very simple idea. Again, the second direction, how you can achieve multimodality. Just so we have now two, learning some common for image and text space, and then just mapping image to the textual modality and compute the same attention. So yeah, so just from the usage standpoint, so for example, you have sentence, maybe I will try to show it as a demo if I can. Where I was using that, or maybe our Hugging Face. Yeah, so probably I have that image also in my presentation, but just as I mentioned, we have visual encoder and projection matrix W project our vision embedding into the textual modality. Oh yeah, so prompt, right? Prompt again here is very important because you have to so it takes as input image and text, and in text you have to insert various image in such tag, right? So you add image, you have to add this tag, and why you have to add it? So because then there is a function in Lava code or method that just merge it. Right? Merge input IDs with image features. So basically, you'll just insert image embeddings into that place where you have that image tag. So here prompting is kind of important. There is actually a third way, at least in my head, it generalized like that. So the third way, which nobody use, I would say, is just to have image model that predicts something, and then we use the predicted something predicted based on image model and a class or something like that, and put it to the textual model. So it's very stupid way, not stupid, but very straightforward way to achieve multimodality. But yeah, just want you to know about that. So that's it. That's it. I mean, there are different models like LavaNext, Fido, etc., etc. Yeah. Maybe some questions about the how to achieve multimodality.
So the third way was to do what?
Okay, so you have, I don't know, again, some classification model that works only with images. And okay, so you have two models that process only image and only text, right? And for example, you take image, you predicted classes, right? I don't know, human, car, whatever, and then you put it to the textual model. If you have a question, what is on the image, right? So you have, okay, again, one more time, you have two inputs. What is on the image and image itself? You have the model that classifies image or segment image or whatever, and based on the image model, you predicted classes, and you put those classes into a textual model in order to generate response. Yep. Okay, any other questions? Just maybe how to use it. Really, it might be really not stupid, but just straightforward questions. Anything. I'd like to answer them.
So what are the like projects, ideas maybe that you would like us to collaborate with you?
That's the next part of my presentation. Yeah, I actually at this point, for next 3 minutes, I want to understand that you understand the ideas behind multimodality. Okay, if you have the understanding of those ideas, I have a question to you. How to do it in local source language? How to achieve multimodality in Ukraine? Just let's brainstorm.
Use some data augmentation, try to find similar words via some similarity and just augment data sets.
You mean just augment it with adding Ukrainian language and training, just the same pipeline, right?
Yeah, actually you have a sentence like with the orange juice, with the apple juice or something like that. The second idea is to also related to the augmentation is to just take the English data set and translate the textual part to the Ukrainian.
Yeah, might be done. Some other ideas. Okay, I'll give you a hint. Knowledge distillation approach. Have you heard about that? Do you think we may use it here? Okay, so the very famous approach, for example, that multilingual clip using is knowledge distillation. Basically, we have a teacher model that represents English language. And we have a student model that represents the Ukrainian language, right? And by represents, I mean you just have a textual encoder that encodes English and Ukrainian. You have to have parallel corpus, right? And then you have distillation laws. It might be, for example, MSE, mean squared error, and you try to minimize distance between teacher embeddings and student embeddings. And what is the problem with that approach? Problem is translations. is a spoiler, but and it's quite a challenging task to find a parallel corpus between English and Ukrainian and good corpus. I mean, again, I will discuss it later, but parallel corpus is a problem. And for this approach, it has to have the good parallel corpus. And another problem is also that, for example, the multilingual implementations of CLIP that I have used in my research, they again do not include the Ukrainian language. So Ukrainian language was represented only by Russian language, or maybe some other languages that relate to Ukrainian language. Okay, and another way to achieve multimodality, I know I never saw it within the papers, but the idea is simple. You just put the distillation loss not to the final layer, but some in the model in some middle layers. Right. Again, we now move to the multiple clip. So the logic is the following: you have a clip, and you have modify or make it to work with some low resource language using the knowledge distillation or teacher-student approach. So again, you have a English encoder, Ukrainian encoder. That you have to learn the Ukrainian encoder, right? And you learn it by minimizing the distance between those two. So you have embeddings of a sentence in English, embedding of a sentence in Ukrainian, you minimize distance, and then you use this encoder. So that probably it will learn enough information to encode the sentence. Make sense? Any questions? Okay, and that approach called it's called the teacher-student approach. It's not complicated stuff to explain, just a lot of stuff to explain, and it is just a nice visualization. It's a visualization from a paper called "Making Monolingual Multilingual." It's again a paper produced by Irina Gurevich, Ukrainian scientists, and yeah, they just use this approach to fine-tune the model to work with low resource languages. And as I mentioned, okay, they use a bit more complicated loss here, but they have teacher-student that encode English language student model that encode German language, and they minimize the distance between teacher model and trained encoder on English and student model that learns to represent again the same English sentence and German Deutsch sentence, and they minimizing those two distances. And outcome of this approach is that the student model will know the German language.
Yeah, but here the second MEC loss is between the English sentence factor and the German sentence factor.
Yes, that's okay. I expected the question: why do we minimize student English sentence again with teacher English sentence, right? I know that's just enhancement to that idea, right? Some improvement.
So, actually, so we try to make the English sentence factors be very similar to the German sentence factors.
Yes.
Okay.
Yes, and also here they added additional part to the loss by making student model to learn also English sentence and minimizing that distance.
Actually, we minimize the sum or the average of the
Yes, I don't remember sum or average, something like that. And here, that is actually the idea that it's used also in multilingual clip. I mean, there are different implementation of the teacher-student logic, but the logic is the same that we just discussed. You have an image of the cat and textual modality two cats, right? And you have those parallel corpuses, right? And you have clip textual in modality in English language and in other languages, right? So you have to have these parallel corpuses, and you minimize MSE. And then as an outcome, you have the textual model that works, textual encoder that works with different languages. And this is the way the multilinguality, actually in that case also cross language performance is achieved. Any question to this? Okay, then the next part, we have still 40 slides, 50 slides, will be about the tasks that I'm currently working on. Actually, the first task where we can collaborate was word-sent disambiguation. The next part will be about visual word-sent disambiguation. So now we have to decide whether we make a break right now, I don't know, 10-15 minutes, or you want to proceed, or you have another question, or you want to end this session. Everything will work for me.
Break.
Okay, 10-15 minutes. Okay, then let's meet here 15 minutes. But in English, or begins Ukrainian, like also can choose either option. Okay, so now visual word-sent disambiguation for the Ukrainian language. This is part of my research that I was doing. I've been doing at the part of my PhD, right? And I want to start with definition of the task. Okay, before all of that, that is my second article that was also published in UNLP this year. So you also actually might read just this paper. I can share with you the links. And the main goal of the visual the task is to identify with minimal contextual information the most appropriate representation of a given ambiguous word homonym from the set of 10 images. Might be complicated, but let's proceed with an example. So we have word, again, kosa, my favorite word. We have several definitions or meaning of the word kosa. And we have images, right? So we will discuss images a bit later, but the point is right now that we have ambiguous word definitions, set of 10 images, and minimal context provided, right? And the point is, by merging, by combining ambiguous word kosa and minimal context Volossia, retrieve the image that corresponds to the particular combination of the ambiguous word and minimal context. In this case, we want to retrieve the braid, the image of the braid. Any question to the task definition? You may ask, why do, like, probably you may think like, why is this important? Like, I mean, what are we trying to achieve with that? But yes, the point is that we have the word kosa, and we don't know what does it mean just by saying kosa, right? Because it may mean anything. And by adding volossia, we add some, like context to the word kosa, but we don't say directly that це є заплетене волосся, там, умовно, жінки, що, ну, так далі. Yeah, so we just provide minimal context. And based on this combination, we want to model multi-lingual model to disambiguate this combination and retrieve the correct image. Yeah, and again, you know, this is we do not have such a data set in Ukrainian language, right? Obviously, and that's why we collected such data set and or benchmark, and each entry in the benchmark includes a target word, homonym in particular sense, one or multiple trigger words or the context. So those are the words that are enough to identify the correct definition of target word when considering the association between target and image. So for example, volossia. Obviously, we have other examples. Kosa as agricultural hand tool and trigger word знаряддя праці, or kosa as a landform with trigger word geography. Right? The next part of each entry of the data set is images. We have positive image, so image of the braid. We have 3 images of alternative interpretation of ambiguous words. So in other words, in our case, this is landform and agriculture hand tool. We have 3 images of similar concept within the same domain. So kosa volossia, here is some punk girl, punk, and just images that contain hair, right? And 3 images of randomly selected concept. And I expect to hear right now the question, why do you have such particular structure of the data? I mean, why do you choose, 3 images of randomly selected concept? Why not something else? The answer is very similar. So we inherit the structure of such a benchmark for English language. And the point is to incorporate that benchmark into the global, not global, but English version of the VSD task, so that people can also evaluate their models on Ukrainian language. We've done that on the purpose. And the second question that I would expect from you, like, how do you collect such a data set? Any ideas? Yeah, you're right. I mean, but that was our second stop. The first stop is словник омонімів української мови. Again, very complicated work, because we found the author of this dictionary and we asked the permission to use this dictionary. That's a very important remark. Another stuff that this dictionary existed only in paper. Not the paper, but PDF, but not copy-pastable PDF, right? So you have to apply the OCR and stuff to receive the programmatically accessible dictionary. And okay, we receive it, but we are not domain experts. We do not know the Ukrainian language in that level. We need to know it. I mean, all the stuff, like, for example, what homonyms to choose, right? We, from the words and disambiguation paper, we know that it's quite complicated. As we discussed, we have such words as підкурювач, kosa in the meaning of selzinka. So it's like you know, it's kind of complicated, but looks probably not so complicated. So here in this project, we combine we have a team with the domain experts in Ukrainian, and those are philologists from the UCU. So they are our domain experts, they are our annotators, you may say, and they choose the homonyms that announce of high frequency of usage in Ukrainian language. So they were responsible for choosing the homonym. Next part is Wikipedia. Yes, we use it as a source of positive and negative image. positive image is the title picture of the target word from the Wikipedia, right? So kosa as an agriculture tool, we have Wikipedia article titled image is positive class, right? And the negative image are collected from also from Wikipedia articles from the same domain as the target word. So if you go to the Wikipedia, for example, word kosa, it contains the category, it is within, it belongs to the category зачески, and you have plenty of articles, and we, like, again, in some unsupervised way, we chose 40 images in that way, right? And after that, our domain experts, our philologists, kept only 9 most suitable images, like 3 for each type that we discussed previously. Sometimes we like within those 40 negative samples that were like they couldn't find any suitable image. Then they provided image on its own. We use images only with the Creative Commons license, so we can distribute the data set, and it's like it can be open source. Okay. And the most complicated part is those trigger words, right? Minimal context like velocity, because they have to be challenging enough so they don't reveal images meaning of their own. But you have to have the target word in order to understand the meaning, the full context. Okay, that's something we were discussed previously. Again, we have velocity, but we don't have the detailed description. And evaluation process. So we combine target word and trigger word and have a list of 10 images. And then we calculate embeddings for each image and for the target word plus trigger word. And we calculate cosine similarity between each image embeddings and text embeddings. And you can do that because of what? Because they're in the same multimodal space, so that you can compare them. And we choose the image with the highest cosine similarity as our prediction. In order to like as an evaluation matrix, we use mean receptional rank, which actually simply tell us how quickly we find the correct answer, and hidden one, which actually accuracy, whether the top retrieved image, I mean not top retrieved, but the image with the highest cosine similarity is the correct image. So we measure those 2 metrics. In terms of benchmark size, at the time of evaluation, we had 87 homonyms. Right now, we have more than 131 homonyms, and our work continues. I mean, after this presentation, I will have a meeting with dean. Not dean. It's like head of program within the I don't know how to say it. I always forget the word for humanitarny fakultet. But we'll have a meeting and we'll continue this. I mean, we still working on that project. We want to cover much more. And about the evaluation results. So as you may see here, different models, multilingual clip, GPT-4o, multilingual clip, GPT-4 vision, multilingual clip, multimodal embeddings from GCP, that the name, I don't know what the model is there, and Llama. So basically, we covered those approaches before, and here's the matrix. As you may see, all the results are worse than the baseline for English language, right? Which actually showed that there is an underperformance for Ukrainian language compared to the Ukrainian, to the English language, and we have like a room for improvement here. And main contributions here is that we introduced such a benchmark for Ukrainian language that integrates visual and textual modality. We assessed it, right? So we like measure the performance of different models on it. And right now, by this QR code, you can access it. It's still a Google Drive. I'm working on some web page where you can download it, but believe it's like a lot of work, But yeah, you can use it as it is. I plan also to release all the code on the GitHub, but it takes time. And next steps, as I mentioned. So we also plan to enrich that homonym list by adding units that haven't been documented in Ukrainian. Now, lexicography yet, okay, complex stuff, but simply we want to use the real language, right? For example, bot. Bot in the meaning of programmный agent or software agent, or like you may use different meanings here, or grad. For example, grad now has a meaning boiler machine, which is very relevant to Ukrainians right now. As I mentioned previously, we don't like the whole point of my work is not doing something that people can't access, can use, can work with. The point is to do something. I understand that it's not a top priority. I mean, it's not drones, it's not something like that, but I believe that it is very important, and I have a reason for that, which we might discuss later. But the point is, I want to integrate that benchmark to the English version of the benchmark. It's possible. I know that guy. I mean, I know his email, so at least I can write to him and try to merge English version of the benchmark with Ukrainian language. And yes, we will release this benchmark. Okay, now we have like two directions within this track. We actually working on the dictionary itself. It's a part of philologists. They want to build the top high quality version of the dictionary of homonym for Ukrainian language, contain those words like bot, rad, etc. Because we do not have good dictionary. I mean, those dictionaries that we're using is dictionary from 1991 or something like pretty old. Okay, that's it about the visual word send disintegration task. If you have any questions, please ask.
Can you slide several slides back so I can just
Which one?
scan the QR code?
Yeah, I can share the link in private or maybe some other questions. And then you were asking about collaboration, so it's one of the directions because right now we are working on building a clip, training clip on the Ukrainian language. The bottom line idea is to just translate the data set, web, image, text that we were discussing when we were discussing clip, just translate it into Ukrainian and train clip solely on Ukrainian language. It requires a lot of resources, but it's a first step for us. Any other question?
Is the reason of worse accuracy on Ukrainian homonyms because of the probably distance between embeddings in Ukrainian homonyms and English homonyms? So the question probably did you make some analysis or visualization? Example, maybe English homonyms are much closer in their meaning than Ukrainian, as you said.
Yeah, I understand the nature of the question. Partially we've done it. but it was such a big work to compile the data set and make it just work. So due to latest UNLP, we just presented dataset benchmark and evaluation without any ideas why it works or why it doesn't work. But I have a couple of slides based on your that will answer your question. So I will mention when I come to the slides. But what I can say from our today's discussion is that Ukrainian homonyms are complicated because we have such words as Pitkurivach and other, believe me, a lot of different pretty complicated words. Okay, now let's proceed with stability of multimodal LLMs. It's a very interesting task. I mean, we didn't create the benchmark right now for this task, but the goal of this task is to assess multimodal models' robustness by evaluating the consistency when synonyms words replace each other in textual inputs with unchanged visual inputs. Again, example. So we have Vila Sosnivska на вулиці Чупринки, and we have one textual setup. Розкішний історичний будинок з високою архітектурною цінністю and занедбана стара оселя, яка нікому не потрібна. Так? And we predict the first class here, right? And now we have the second textual setup where we put the synonym here. So instead of oselya, we put budynok. And the problem is that the prediction has changed. Okay, I mean, yeah. So the objective of the task is to retrieve the same, not the same, but based on the predict the correct description. Let's say simply embedding of this image has to be close. When we have embeddings for two sentences and two sentences here, when we calculate the distance between image and each of these embeddings, the same sentence has to be the closest in both textual setups. Okay?
The distance should remain, yes?
Sorry?
The distance should remain.
Yes, yes, the distance should remain. I mean, it might change a little bit, but the point is that the highest sentence is the same.
I guess for textual stuff too, it would be also beneficial to replace budynok with oselya. Maybe.
It's only one case of the experiment, because when I was starting playing with that, my initial experiment was like this. Розкішний історичний будинок з високою архітектурною цінністю, занедбана стара оселя, яка нікому не потрібна. And then I put оселя here and then here, and the prediction has changed. So, and it's so straightforward, but that's the problem, because if we take the experiment that I just described, the sense of the image like totally changed, right? And it's also, I mean, speaking of the relevancy of such solution, for example, if you say about товари подвійного призначення that you can sell on OLX, right? If you say drone, for example, some drone, OLX will might take a look and say, okay, you are selling the drone of, I don't know, some charity fund or whatever. But if you say пристрій, що літає, then it might be okay, right? I mean, you in that case you may sell actually that drone, and so that's actually maybe a part. I'm not speaking here about my business understanding, but you see that there is very very relevant tasks, even for some businesses. Yeah, again, evaluation process. So calculate embeddings for each sentences and image, and again, we can compare them. I hope that you understand that they map to the same space, so that you can compare embeddings of image and text, and you choose the highest cosine similarity here, and you do the same in the textual setup too. Again, not again, but let's proceed with an evaluation matrix. So we measure instability. It's like my own idea how to measure the performance. I don't follow any previous research on that topic, but so we measure the number of changes in class prediction divided by total number of evaluations and multiplied by 500. And also it's like additional metrics. It's like how average distance. So the logic behind those metrics is the following. For example, you have budinok, right, and ocelli, and you measure distances, right, between image and budinok, image and ocelli, and you have average distance. And then you exchange classes, and even you might receive the correct prediction, but the point was to test how sure the model is, because if the distance between positive and negative class is high, that's good, and then when we exchange synonyms, the distance is like between like classes is so low, even like 1% distance, even if we correctly predicted the sense. Okay. Yeah, evaluation results. So it's not so well structured benchmark right now. I just I mean, it's an idea in progress. Yeah, and the benchmark size. Okay, sorry. The important part here that you may see instability. And you may see that instability is higher than instability for the English language. But also for English language, you also have that instability. And sometimes it makes sense because budinok and chata is probably very different words, right? Because if you say, yeah, they have a totally different meaning or semantic context for us. But for example, if you use budinok and ocelli or budinok and budivля, it's pretty similar words even for us native speakers. It's not so important information, but yeah, so I'm just working on that idea. I'm not even started to collect the benchmark because I need a team here to do that and to help use it. And right now I have like 30 images for each class and 5 sentences per each word. And actually, this is part of our practical task. I know that we don't have much time. Actually, I envision that we will end up in that situation. So my point is to introduce you the setup of that experiment so that you can investigate this stuff, okay? And further investigation. So again, multilingual clip, and it's answer to your question about analysis, right? All the training non-English data was machine generated. And the answers didn't include the Ukrainian data in the training data set. That's the second problem. And to investigate the representation of Ukrainian synonyms within this corpus, we replicated the preprocessing condition used by the author, and we end up in this situation. For example, I took all sentences from that corpus that they used to train multilingual clip, and I took all sentences that contained word cottage, right? And all of those words were mapped to cottage, which is fine. But I did the same experiment for home, house, and building. And as you might see, the word hata is not represented in those translations. Again, very obvious. It's so obvious, but how do we expect it to work with the word hata if we just don't have such words in the training dataset? And actually, okay, hata, let it be, but oselia, it's quite common word, even budivlia is not so well represented. And that is about your question about analysis. It's a part of it. And it's maybe similar example that film, we don't have strichka or kino. Film and movie are represented just as a film. And this is the second direction where I want to move in order to improve the performance for Ukrainian language. Any questions so far?
Are there any way to find?
Well, I'm not sure about like the.
Are there any way to analyze like arbitrary corpuses of text and make those hata, oselia, budynok have very similar embeddings, so we can just say that okay, those words are like it's actually the same word in some sense, and then
I mean, I don't know about the solutions, such as solutions, but so you are asking whether there is a way to mitigate that issue, or okay, clarify the question, please.
okay, can we just say that okay, it is the same word? Yeah.
Yes.
Because they are actually very similar. Those budivlia, budynok.
Yeah, we can. It's again an guarding question. I don't know because, for example, hata, as I mentioned, is quite different from budivlia, budynok, right? So it depends. It depends. I'm not sure that if you just use the same embedding for all the synonyms, it will be a good idea. But you might think about normalizing that stuff. And that's what I was thinking about practical. So for example, you just compute the embedding for the sentence, let's say, розкішний історичний будинок з високою архітектурною цінністю. And you take the word oselia, you add it here. I mean, you simply, for example, you compute two embeddings right now. Розкішний історичний будинок з високою архітектурною цінністю and розкішна історична оселя з високою архітектурною цінністю. And then, when doing the prediction, you, for example, calculate average between those two embeddings. For example, it's one way how I envision mitigating that issue. And that's actually something that I want you to experiment on the practical part. Yep. Okay, and last.
I have a question.
Yes.
So my question about like the volume of the issue, maybe about this underrepresented words. If I understand right, you have like 5 sentences per word.
Not. I have 5 sentences when I'm testing. Okay.
Okay, so I just guessed maybe more data.
No, no, I
So
mean, when I speak about the word film, it means that I took all the corpus that was used to train multilingual clean, and I take only sentences that contain the word film, it's like thousands of them, and just took words film, kino, and strichka, and calculate the just occurrence of that
okay.
word. Okay, and again, investigating, not again, but the next stop, the final stop for today, investigating the semantics of token embeddings in the Ukrainian language. First of all, do somebody know what is token embeddings?
Just embeddings, but for them.
In some sentence, in some sense, yes, you're right. But in more details, token embeddings of different languages, different language models hold a specific meaning. That was the idea that was discovered in this paper. For example, XLM Roberta identifies semantically or linguistically similar tokens within the same language, right? So what again is a token embedding? Is an initial input embedding of each token. So you have token, you map into token encoding, and then you map that encoding to token embedding. So encoding is just number, embedding is embedding, okay? And they discovered very interesting insights that in XLM Roberta, which is one of the first multilingual model, those tokens, when you just simply imagine you have word машина and вантажівка. If you encode them with that model, take an input in encodings, and for example, perform key nearest neighborhood, those words will be very similar. Those embeddings will be very similar, okay? And based on these findings, we aim to analyze the synonyms for words that are written identically in both Ukrainian and Russian languages to assess them on then models potential bias towards higher represented language. And what do I mean by that? That, for example, I take the word blogger, right? The same word for English and Ukrainian. And you may see how many Russian words are here, or how many words that spelled the same, written the same in Ukrainian, in English language are here. For example, volunteer, designer, jurist, blog, all of those words are written the same.
It's English word.
Which one English word?
Lawyer, smartphone,
Yeah,
hacker,
yeah, but this is not the main point. The main point here is that, okay, for example, let's take word літак, right? The top closest word now is самолет, right? Let's take hacker, so шпион. And you see that it's not a problem for now. It's like an idea that the same words that are spelled or written in the same way in Ukrainian English language might have the bias towards Russian language. And the next slide actually represents it. For example, I take the sentence заходить на посадку and compare it to the words літак, самолет, машина. And you see the самолет is the closest word. So probably we have a bias towards Russian language here. And yeah, finding here is very important to balance the training setup when you perform multilinguality. That's it for the presentation part. And we have half an hour to discuss the practical part, but let's spend a couple of minutes to discuss the lecture. I mean, any questions over the content, anything.
So actually, in these models that were biased toward the Russian world, actually, what about the datasets that was trained on? Was it like filtered, cleared, and so on from the Russian words or not?
No, nobody care about that. That's the problem. I know Roberta is quite old model, I would say. They just took some texts that was very available.
Okay, but can we try to filter it out by some heuristics, by endings like lot?
Possibly, it's a direction of the research. If you want to do it, you're very welcome.
Or use Russian dictionaries to filter, like to clean dataset.
Yes, yes, that's one way to mitigate that issue.
I believe those Russian actors of those dictionaries wouldn't be like the against our.
Yep. Okay. Any other question?
Is there a way to handle such case with existing solutions where the meaning of the word in the sentence is indirect? I mean, like переносное значение.
Okay. Can you provide an example of such sentence? Or maybe elaborate more about the idea. So you see.
I mean, when the sentence is like kind of metaphorical. So how to distinguish between this sentence and the normal one?
I believe we have to go into details here a bit more. So probably let's discuss it after the lecture, because it's like there are different ways how you can proceed with that. Okay. If you have no more questions, I have a code which I used to evaluate the performance of multilingual clip on with the synonym substitution task that we just discussed. And first step here, let's go through the implementation. So you don't need anything special here, just GPU and install of the stuff that is here. In this cell, there are different multilingual clips that you may use, that I used to work with Ukrainian actually. And I have images. I have images of budynok, chata, and ganok. For now, those are just images from Wikipedia. I just gathered them on my own from the Google and stored like this. So just images, right?
Possible to turn on the light theme.
Light theme? Oh, I don't like light theme. Okay, I mean, it's a good suggestion. I just don't know how to turn it on.
Probably some browser settings.
I believe that this is a Google Drive.
справа, справа, там. Правіше.
Yep, we have that. Thank you. Okay, so we have images of hata here, of ganok, sorry, ganok here. We have images of budinok, many images or something, just pretty nice buildings from VIP. And where I want to go here, not here, here. Okay, sit down. Okay, no. Okay, collab. It's not going to be. Maybe I can make it like this. Okay, there is not so much code here, but the point is that you like we have just upload those images, and the function load images from folder will calculate the embeddings of images, right? And now that stuff that I mentioned. So budinok text examples. We have again, it's research code. Please don't judge me so much. Zero is розкішний історичний будинок з високою архітектурною цінністю. And other examples of the same stuff. Same stuff, it's same meaning with the same word, okay? Then we have занедбана стара хата, яка нікому не потрібна. Again, хата, будинок, будинок, хата. And other examples with the same direction. We have two, розкішна історична хата з високою архітектурною цінністю. So in the zero, I inserted the word from one. Make sense? Just put in this sentence the word хата. Okay? And third, занедбаний старий будинок, який нікому не потрібен. So I put the word будинок here. And now it's like a tricky game. So the point is, so you have image, you have 0, 1, 2, or 3, and you can provide different experiments. For example, you might take this and this, predict text based on image. Then you might take this and this, predict text based on image. Okay. And we have the same for будинок, оселя, будинок, будівля. The same for ganok. And we have the function run experiment, right? So what will it do? It went through text examples and just compute the same stuff that we just discussed. We predict the change of the class and average difference, and returns the same analytics, right? For example, when we change budinok to hata, predicted class changes. The instability matrix is 0.1200, let's say. And here is some to-dos. So first task is run the baseline, get familiar with the code. The second task is add your own class and evaluate the performance. So I really like you to add, we have 3 classes, budinok, ganok, oselya, and I'd like you to experiment with that and add some custom class that you'd like and understand how it works. Whether it become better or worse. And the third task is try to improve stability performance. For example, by averaging the synonyms, something we just discussed just previously. So that is the setup. And now the discussion part. First question, whether you want to do it. Second question, we have 15 minutes, probably you won't be able to perform it here, but you might do it as your project, or how to call it, within this school. And you might play with that, and maybe you want to proceed with this work, because there are many different strategies that I have in mind, much complicated than just averaging synonyms, that might improve the performance, such as Google loss, for example. Have you heard about Google loss? So that's the point what you might want to do that one. But let's spend the 15 minutes for discussion. I mean, I can share the data set and the collab notebook with you. And yeah, I need an input from your side. Input whether you want to work with that, and what the outcomes, what the expectation you want to achieve with this the task. I mean, I wrote mine.
Question. All the examples today were about nouns. Yeah.
Yep.
What about verbs?
I don't know. I mean, nouns pretty broad topic still. If you want to experiment, please. I even, if you can find an error within that code, that would be also perfect for me. If something doesn't make sense. Yeah, if you want to discuss, discover adverb or other part of language and think of mitigation of such issues, that would be perfect. Yeah, so 15 minutes for the discussion. First of all, if you want me to share that task, I have to understand how to do it. You have some team.
I will add you to Telegram chat. We just created it like for the metro lecture.
Okay, great. Second task. Well, is anybody ready to work with that as a project or any other ideas? I mean, I shared with you my vision, so you might use this code, you might receive this, let's say, performance evaluation, and yeah, I don't know what to add.
So it will be cool.
Sorry?
It will be cool, but you already started to work with drones, so yeah, sure.
Yeah, no, I mean, I won't be offended. I just want to make your results better. I can just share that code. We can work on this later, because as I mentioned, we don't have so much time to have a, at least from my understanding, good, you know, like workshop session, because I had a lot of, you know, prerequisites, let's say. So as I mentioned, we may just elaborate on it later.
So this question was due to our today's session. If you want to proceed with the notebook or the project that we do in terms of the school in general.
It's like both question. Even the third question is like, as I mentioned, if you want to proceed in the research and in that direction, it's a very nice topic, because I mean, we are starting this direction within UCU. We are pretty much mature. I'm also working on the collaboration with Estonian University because they're also working with lower source. So it's a lot of possibilities here.
I personally find this topic very attractive. It will be beneficial, I think, to make more technologies in the Ukrainian language space. But I just wonder, maybe you already know about like the citations that you meant, like for the 2023 paper. How does it like work in the production? Maybe there are some applications that already use it besides like academia.
In VSD.
Yeah, like in Ukrainian. So I'm just curious, maybe there are some like industrial application that just will fuel my interest as well.
I don't know. I didn't heard about one second. About industries. I just may show you that our model is the second here in the long UK space. So it has almost 200 downloads, and like, for example, Dragoman is a model produced by Yuri Panev. He'll be here tomorrow, and he has like a repo, some marketing stuff that he's doing. And we don't have anything. We even don't have a repo. So like it just deployed that model here because one of our colleagues asked us, and that's it. People just download that model. I don't know about that their let's say further usage of that model. But I believe that it worked. I believe that even if you proceed with a VSD, I mean solely VSD without multimodality, it's also a very prominent topic, and there is a lot of stuff that might be done there.
Thanks.
Yeah, maybe you have some questions regarding, I don't know, this code. Anything. I'm pretty tired of speaking, so but we have 10 minutes, and I'm perfectionist, so we have to discuss something for 10 minutes. I may share this code with you, and you may just, when you have time, just play with it. Maybe we can collaborate, like in terms of some, in your, for example, diploma, stuff like that.
I have like a note about the 100 laws. Just my guess is it is less sensitive to outliers, maybe because I think that Metro, yeah, because I think Metro in the first part just mentioned it in that part about estimators, how to deal with noisy data. So is it right?
I know the Humber or Gumbel loss.
Gumber, maybe. I don't know how to spell it right, so
Maybe it's different because there is a Humber, the Gumbel softmax loss.
No, it's not like G, it's by H. So yeah, I just found another loss.
Yeah, so they, about this loss. So that I know about this loss because of word2vec model, not word2vec, WAV2vec 2 model. So it's ACR model, automatic speech recognition, and it was trained again in semi-supervised way using triplets, and using this Gumbel loss actually helps to perform quantization of the. Not quantization, I mean of making the model smaller, quantization by quantify. Okay, it's a total different lecture about this loss. It's kind of a complicated loss, but the point is that it can give you a pretty good weights of what synonym is better in that of this direction, like that of the sentences based on the context. So if you have no questions, that would be it from my side. We still have 7 minutes, but I believe that it's fine.
Well, I actually have like more philosophical question I may think about like the concepts, words that do not have like exact visual representation, how to deal with them in multimodality, like some abstract ideas.
For example.
For example, maybe I don't know, like soul.
So if there is an explicit visual representation for a soul, just open the Bible.
Well,
Yeah, there's some Bibles with pictures for children with pictures and images. Just look for a nice painting of the soul, and that would be a visualization. Just invent a better example. More
variety.
variety. There's a picture of manifold in any mathematical textbook. Use manifold for that, for a variety.
I would say
It's always an illustration. You have to think about it, and that's it.
Yeah, I would also add this. There is like a also business perspective on that question. For example, if you try to build a model that people will use, probably the best image is the top one image in the Google, because people associate that concept with that image, right? And that might be an answer.
It would be good, cool to try to type in variety in Google Images.
I think it might be biased to my search history.
You may average it by asking your colleagues to do the same. Find an intersection or a union. Yep, sorry.
What about some terms like metaphor?
Metaphor.
Yeah.
Yuri, could you please Google metaphor just to show it on screen?
Or
Polysemy or something like that. Google Images. Is it?
nice.
I lost. I would offer you slightly different text. Illusion, for instance. Can you visualize illusion?
Optical illusion.
Not illusion, but illusion. Illusion with A at the beginning.
So we can use not the images but the text actually for that.
Yeah, but that would be the same modality.
But we can use the image.
Image sans disambiguation, you mean?
The screenshot of the.
No. You have to.
Yeah, while working with some technical literature, for example, yeah. What is the picture, the image of laws? Machine. For example, all the terms, technical terms that should have some definition, textual definition.
You have to use two images. The first is very thick and full wallet, and the second in a row would be an empty wallet. That would illustrate the loss.
Okay, but in our machine learning domain,
This is, well, the meaning is the same.
yeah,
You lose something. You lose. You have a decline in the value, or an incline in an error. So the more errors you make, the more money you lose. So
Okay.
even in machine learning.
Yeah. Okay, I agree, but Euclidean laws.
Euclidean loss. Yeah, just projected to three axes, and that's it. Make a 3D image of the loss, and that will be an Euclidean loss.
But it's really complicated to cover all the terms.
If you want one more illustration for a metric, just use Manhattan distance for it. Very well illustrated, isn't it? more tricky questions? There are some chocolates on. Okay, you may leave it for tomorrow. So we'll call it today. Yuri? You still have some time, I believe.
Yeah, like 2 minutes, but probably I have flour.
Okay. You close to still.
Yes, 3 hours.
Please stop the recording.